Hey gang, this is Mr. Schmidt for the November 17th recap of our discussion of the upcoming physics lab and the previous assignment here. One thing I want to note before I turn off this page is there are some good examples and explanations in a video that I posted for later this week. That physics teacher really likes their video editing, so that's why I say it's weird, but their physics is spot on. So feel free to look at that if you get further confused. Okay, so we're talking about the physics lab here. So let's go to the very beginning if we can. Okay, so that was, we'll talk about that with the assignment. So our goal is to try to draw the force diagrams and calculate friction and calculate the coefficient due to friction. Okay, so the first thing is we have to figure out what data do we need to collect to do these calculations. Okay, and the key things are going to be the angles of where it starts moving, what materials you have paired together. Okay, so like a wooden board and a plastic charger. Okay, those types of things can be very important to collect. You may also want to know mass or acceleration. Those can be useful to have in your back pocket as things come up as well. Okay, so remember, this is still our governing equation. Our lab is to try to find mu. So first, we're going to have to somehow measure or calculate these two forces, and then we can solve for the coefficient. Okay, so the setup's just like a lot of the other things we've seen in our assignments and in our labs. We're trying to put an object on an incline, and then we're going to slowly raise the incline until it starts to move. So as we raise it, we're going to be changing our axes. Okay, and so here I have a charger sitting on top of a wooden board. So I have plastic on wood. I have rubber bands sitting on top because I wanted to keep mass constant for this one versus my second example. Notice I have my phone clamped up here so it'll show me the angle. You don't have to use a clamp for your phone. I'm doing this so that the video is clear. You can set yours up slightly different if you want to. Okay. So here we see I start raising the ramp. The angle's changed. Note this is not moving, which means the force of friction is still greater than the x component of gravity. So as I keep turning this angle, the x component due to gravity is going to keep increasing. Okay, and then we see eventually the x component of gravity exceeds the force of friction, of static friction, and it begins to move. And it switches from static friction to kinetic friction. And kinetic friction is a much lower coefficient, which means it's going to really start moving quickly. Okay, at least relative to before. Okay, so it will break free and then start sliding. So this is kind of your locking up your brakes scenario. Your tires were rolling and had a static friction point. Then your tires lock up when you lock up your brakes and you slide off with no control. So that's why we don't lock our brakes. That's why cars now have a coefficient of friction. It's high due to good tires and anti-lock brakes. Okay, so here I would pull off this number as a very important number. Okay, so I'm going to go through a couple other examples. Your goal is to use 5 different materials. So I decided to use 3 different examples here. So here we had plastic. The rubber kept the mass the same as my second example. Okay, my second example is the charger with the rubber bands again. So the exact same mass, the exact same force of gravity. Saves me a little bit of math, by the way. Okay, and then we're going to have to measure the angle again. Okay, so here we see the angle is about 39 degrees. Okay, so exact same force of gravity, exact same base, but our coefficient of friction's changed because, of course, rubber has a greater coefficient of friction than smooth plastic does. Okay, all right, so now we can start thinking about how are we going to draw this, how are you going to calculate it. So let's look at one more example and then look at how we're going to calculate this. Okay, so when you set this up, be super careful with anything that is breakable. So I highly suggest like plastic or wood. If you use something like ceramic or glass, think about what is at the end of the board. Or do you have a pillow down here? Are you doing this on the floor? How are you going to set this up that you're not breaking anything? Okay. All right, so right in there we can see somewhere around 24 degrees is when that X component exceeds the force of friction. And so we can start using that angle for our measurements. So let's use this example and that 24 degrees for our drawing here. Okay, so when we do that, what we're going to see is we have our mug. Our mug's pulling down with the force of gravity. Okay, and we have the force normal pushing up. So we have a force normal here, and we have a force of friction. And if this force of friction is greater than or equal to the force in the x direction due to gravity, this number is bigger, then it doesn't move. If the force due to gravity is bigger than the force of friction, then it moves. So we can find where does this line break? Where does it start moving? And when we find that, then we can find our force normal and our force of friction, and then we're off to the races because now we have. Okay, so now we can use SOHCAHTOA to find these two numbers, plug them in here, and solve for mu. Okay, I cannot stress enough, if you do this symbolically using letters and not putting in any of your measurements yet, you're going to find that the algebra gets a little confusing, but simplifies way down by the time you get to the end. And if you solve it all symbolically and you get the algebraic solution in terms of symbols, in terms of letters, then you do your 5 different examples, and you only have to plug it in at the end. And you don't have to go through the algebra 5 times over. Okay, because the fact is the algebra should simplify down fairly quickly. Okay, but I want you to look at it because I want you to focus on what is the coefficient of friction. Okay. All right, so last side note for this assignment is how did I get those angles? Okay, so I used Firefox, okay, which gives us our inclination. Okay, there's a number of different apps that will give you stopwatches or inclination or any types of things. But the fact is, your phone and the phone makers want to know whether you're holding it like this or whether you're holding it like that. And so in order to do that, they do use accelerometers. They measure the angle, okay? Same thing of whether you're holding it like this or whether you're holding it like this, okay? That is going to use accelerometers, okay? Now, if you hold it like this, they might use an accelerometer and a light sensor to see if it's close to your face, okay? but they can't just alone use the light sensor, because what if you're in a dark room and you have it like this versus like that, okay? So there's a whole host of sensors in your phone. In addition to the mic and the camera, which can read sound and light, of course, there's other ones as well. There's normally a temperature sensor, okay? All sorts of things that you can tap into using this app or a number of different apps. But again, for today's lab, inclination will give you this one. Just make sure that you tell the software, the app, whether you have it this way, or this way, okay? So flat, upright, or side, so that you get the readings that you're interested in and you put it into your lab, okay? Now, I personally don't care which way you do it. Whatever way is easiest set up for you, that's fine. There's no requirement that you video this, okay? Now, let's take a look at the lab itself. So you pick 5 items. So, I might pick rubber bands, rubber, paper clips, steel. I don't have any paint or anything on this one, so I know it's steel is on the outside. Okay, if it has paint or rubber on the outside, that's obviously going to change the surface, which is going to change the coefficient. So I just choose a steel paper clip. This is acrylic. Okay, this is wood. This is cotton. Okay, now I can go through all of my different steps here. So I've picked my 5 different objects. And then I search for the coefficient of friction. What you'll notice is when you click on these, first of all, they give you a nice little example here. And it'll always be pairs, okay? Aluminum and aluminum, dry and clean. Okay, that's one coefficient. Aluminum and aluminum with a lubricant, that changes it significantly. Okay, then we can come down, we can keep going. Cadmium and steel. So these are all engineering products that they may want to keep track of. Diamond and diamond, amazingly low coefficient. Okay, I've never had a diamond table, so I don't know what that looks like, but I'll take their word for it. Okay, so you're going to look up your pair. Okay, so for example, rubber and cardboard. Here's a good one. Okay, rubber and dry asphalt. Okay, it'd be very hard for me to take asphalt and go like this, so maybe not the best example here. Okay, but you can keep going down. I was actually looking for wood. Okay, wood and stone, wood and brick, wood and metal. Okay, now I can look at some of these things. Look, wax and skis. That's an interesting one to see. Wet, dry, dry and cold. Okay, we see different changes in coefficients. All right, so that's the type of thing you're going to look for. This may not be the best website for you. You're going to want to pick whatever website has the pairs that you use. Okay, all right, so with that, you'll be off to the races on this one, and that should get you started.